All right, party people. Today we're going to be going over a concept for molecular biology. This has to do with hormone binding. What the USMLE is going to do is they're going to ask you a question like, they'll say vitamin A, and then list a bunch of hormones asking you what has a similar binding site. They're hoping that you won't know which end is up. So we're going to break this down and kind of group this into ways that's easy to understand, easy to remember, and that way you won't get bamboozled by their nonsense. Key point number one, vitamin A, vitamin D, and thyroid hormone all have similar binding sites. That is to say that they are all ones that bind to intracellular nuclear receptors. So to memorize this trio, vitamin A, vitamin D, and thyroid hormone. They're lipophilic, meaning that they pass through the cell membrane easily. Once inside the cell, they move through the cytosol, enter the nucleus, and bind to the receptors that are sitting directly on the DNA. These receptors are known as response elements and are typically arranged in heterodimer with retinoic acid receptor, the RAR. So it's important to remember that RAR is not limited to binding vitamin A. It forms heterodimers with receptors for vitamin A, vitamin D, and thyroid hormone. This binding upregulates gene transcription. This is classic USMLE type question. You have to know this. Key point number two, this has to do with steroid hormones. Now, the majority of steroid hormones, such as testosterone, progesterone, and cortisol, bind to intracytoplasmic receptors. Once bound, they translocate into the nucleus to affect gene transcription. What's important to note is that estrogen is the odd one out. So estrogen being a steroid hormone that predominantly binds to the nuclear receptors directly, not cytosolic ones. So do not mess this up on test day when they give you estrogen in that list amongst the other steroid hormones. Okay, next up, we are going to get into peptide hormones. Here, this list includes basically most other hormones, such as, but not limited to, prolactin, growth hormone, insulin, TSH, ACTH, LH, FSH. These are all peptide hormones. These bind to cell surface membrane receptors. So in the case that the question gives you, oh, researchers observe a hormone binding to a membrane receptor, which one is it? Even if you don't know the answer off the top of your head, just look at the choices. If 4 of them are steroid hormones and 1 is a peptide, go with that one because it's the odd one out. Next up, we're going to get into insulin. Now, insulin binds to a tyrosine kinase receptor. This receptor dimerizes before initiating signal transduction. You need to know that insulin upregulates tyrosine kinase activity directly. It upregulates serine kinase activity directly, and that it decreases ubiquitin-mediated proteolysis. Why? Because insulin is a fed state hormone, not a fasting state hormone. All right, guys, time for a final recap. Let's rewind and review what we went over. So, vitamin A, vitamin D, and thyroid hormone all bind to nuclear receptors via zinc finger motifs. This upregulates DNA transcription. 2. Most steroid hormones bind to cytosolic receptors, which translocate to the nucleus. 3. Estrogen is the odd one out, which binds predominantly to nuclear receptors directly. And finally, peptide hormones bind to cell membrane receptors. That's it for today. I appreciate your time. Now go crush it.